Welcome, Quakers and my math fiends, to problem number 31 from section 3.3. I think this is page 125. So I'm not going to do everything in this problem, but I'm going to do a lot of it and try to point you in the right direction and kind of give you some tips along the way. So this problem, we're given a polynomial, and we don't know, we know the very first coefficient, the leading coefficient is 1. But then after that, we have no idea. It's just a, b, and the constant c. So we have three different variables. And since it's a third order, we know there's going to be three factors. And they're telling us that x minus 2 and x plus 2 are two factors. And they're also telling us that that when we divide it by x minus 3, we are going to get a remainder of 10. So using these three givens, we should be able to come up with three different equations. And then with three different equations, each equation will have an a and a b and a c term probably. Then we can solve for a, b, and c. That part is a little tricky because you're used to doing like a system of linear equations when you have two unknowns like x and y. And you have two different equations and you can cancel out the x's and solve for y. This is a little bit trickier, but it's the same idea. It's just more complicated because there's three variables. So let's start first. When you divide by x minus 3, you're going to have a remainder of 10. So I could do a long division, do all that. That would be a little bit crazy. I'm going to use the remainder theorem, right? And the remainder theorem tells you that if you substitute in 3, not the negative 3, because remember, think of that as like x minus 3 equals 0. So the 3 is what I'm going to divide by or put into. I'm going to put that into the x's and then see what there comes out, and it should come out to be 10. And in this case, you'll see what happens. So I'm going to use the synthetic substitution to do that. So I'm going to put a 3 here. I'm going to drop down these coefficients, a, b, and c. I'll do my little thing. Drop that down. 3 times 1 is 3. That's a plus 3. Times 3 is 3a plus 9. Drop that down to 3a plus b plus 9. Multiply that again by 3, and I'm going to get 9a plus 3b plus 27, and then I'm going to have to add c to that. So rather than writing it all out, I'm just going to write plus c. And all of that is the remainder. And they told us that the remainder was 10. So I'm going to say that equals 10. And if you look at this, then you could rearrange this to say, well, that's 9a plus 3b plus c, bring the 27 over, equals negative 17. And you can see that's what I have right here, thanks to Genesis. So this represents what happens when you divide x minus 3 in the original polynomial. And then these two are going to be the same if I do the same process, but this time I'm going to use synthetic substitution and put in negative 2 for this one and positive 2 for this one. So when you do that, you're going to get this and this. You should get that. So check that yourself. So now I have three equations and I have three variables. So I should be able to figure these variables out. And this is where things can get a little messy. But if you look at them, these are very close. So if you combine these two equations, I'm just going to like a little dash line here, and I'm going to subtract this one from this one. 4a minus 4a is going to be 0. 2b minus a minus will be a plus, so that's going to be 4b. And then c minus a c is 0. And then negative 8 minus 8 is negative 16. So that was pretty nice. We got lucky. When we combined these two equations, the a's and the c's crossed off. All I had left was 4b equals negative 16. So b is negative 4. Hey guys, I'm making a video over here, you know. Mm-hmm. Sorry about that, you know. 4th hour, what can you do about that? So now I know what b is. Now you should know b, you could substitute that back in, and then you could create new equations. Or what we could do is maybe we can combine two other equations that will cancel out like an a or a c. And if we do that, then we can speed this process up a little bit. And if you notice, if if I take the third equation and subtract the first from it, that's going to be a pretty good one. I looked at this ahead of time, so I figured that out. So I'm gonna just do this without rewriting it. 9a minus 4a is going to be 5a. 3b minus 2b is going to be plus b. And then c minus c is going to be 0. And then negative 17 minus a negative is plus 8 is going to be negative 9. So 5a plus b is negative 9. I already know that b is negative 4. So I can substitute that right in. Put in negative 4. Add that to both sides. I'm going to get 5a is equal to negative 5. So a is negative 1. And now I know a and I know b. I can put those into any one of the three equations. Doesn't matter. And then I can figure out what c is. So I'll leave that one to you. So hopefully that helps you with number 31. If you need any help, let me know. Namaste.